Yeah. Hi everyone. Can you guys hear me?
Yes, yes,
Yes,
sir, we
sir.
can hear you.
Yes, yes.
Yeah. Can you guys also see the screen?
Yes, yes.
Yeah. So today we'll start with discussing a assignment similar to assignment number 5. Before that, does anyone have any doubts regarding the previous assignment? Okay, great. So I have sent an email to them regarding the third assignment. This time for assignment 5, they have mentioned wherever you have to round off and how many decimal digits you need to have in the answer. Uh, I think soon they'll reply to my email and also clear the other thing with the first question. Okay.
Thank
Yeah.
you, Arpit.
So, sorry.
Thank you for consideration for our
Yeah.
requirement.
Yeah. Uh, okay. So we'll get started. We'll discuss an assignment similar to assignment 5. Yeah. So here we are given a table. Blood urea lowering drug was tested with a placebo, and the number of persons who had urea reduced and those who did not see reduction listed below is a 2:2 contingency table. We want to know if the drug is effective. So here's a table that we are given. It has a placebo and a drug, and in how many people it lowered blood urea and in how many people it did not. So the first question is, what is the chi-square calculated using Yates correction? So it's quite straightforward. So we have the observed table here, which is given. 24 people who took the placebo had lowered blood urea, 30 did not. 45 who had the drug had lower urea, and 33 did not. So for each rows and each column, first what we'll do is we'll calculate the total. Here it will be 24 plus 45, 69. 30 plus 33, 63. Here it will be 24 plus 30, 54, and 45 plus 33, 78. Then we'll find the sum total of everything. We can either add the last column or the last row, and we get 132. Since we are not given any expected values, using these total values, we have to calculate the expected value for all of the tables, all of the cells in the table. So for this cell, how it happens is we calculate 69 divided by 132 multiplied by 54. So it's 69 divided by the total 132. We are taking a fraction and we are multiplying it by the total on the row. Similarly, for here, we'll do 63 by 132 into 54. Here it will be 69 by 132 into 78 and 63 by 132 into 78. That's how we'll get this expected table. So these total values are from the observed total values and the expected values we just calculated. Then, yeah, since we are using the Yates correction, what we'll do is we'll subtract the observed minus the expected. We'll take a modulus and then subtract 0.5 from it. That's the formula for Yates correction. So when we do that, we'll do this for all these 4 cells. When we do this, we get quite similar values for all of them, around 3.7. Then to calculate the chi-square statistic, we need to calculate the uh, square of this term divided by the expected value. That is observed minus expected minus 0.5 whole square divided by the expected value. So we'll just square this values from this table and divide it by values from this table. That's how we get these 4 values. And chi-square is nothing but summation of all of these 4 values. So the chi-square metric is given by summation of observed minus expected is minus 0.5 square by expected. Adding all these values, we get a chi-square value of 1.74. Is that clear?
Yes.
Yeah. So moving on, the second question is quite simple. What is the table chi-square value for 95% confidence interval and upper bound? So we'll take a table that gives us the upper bound values. That is the value of the right tail. Yeah. Then we need to see at 95% confidence interval, that is a 0.05. And since here we are given two types of treatments, placebo and drug, and there are just two options, lowered blood urea or did not lower blood urea. So the degrees of freedom will be 2 minus 1 for the rows multiplied by 2 minus 1 for the columns, which will be 1 into 1, which is 1. So at degrees of freedom 1, from this table, we can get the value 3.84. So the answer here will be 3.84. Is that clear?
Yes.
Yeah.
Yes.
So the third question we are asked, what should be the minimum number of successful persons we should have if we can
Please
conclude
start
that
from first.
sorry?
Can you please start from first?
Okay, yeah. Yeah, so we are given this table in which there's a placebo and a drug, and we are given in how many people it lowered the blood urea level, and in how many people it did not. So the first question is, what is the chi-square calculator? So we get the table, observed table from the question. We add up the rows and columns to get the total values. Then using these total values, we calculate a expected value for each cell, which for this cell will be 69 divided by 132 multiplied by 54. So it's the row fraction of the row multiplied by the value in the column, the total value. We do that for all of the four cells. We get these values. Then we calculate the uh, observed minus expected minus 0.5, which is the Yates correction. Since we are asked to use the Yates correction here. So for each of these cells, observed cells, we'll subtract from the expected cells. We'll take the modulus and we'll subtract 0.5. Here in each of the cases, we get the value 3.7. Then for calculating chi-square, we need the square of this value divided by expected value, the sum of everything. So that is what we are calculating in the fourth table. What we are doing is we are taking this value, squaring it, and dividing it by the expected value. So adding all these four final values up, we get a chi-square of 1.74. The second question is quite simple. What is the table chi-square value? So yeah, for 95% confidence interval, we can see the value here. And since we are given two rows and two columns, the degrees of freedom will be 2 minus 1 into 2 minus 1, which is 1. So for degrees of freedom 1 and 95% confidence interval, we get the value of 3.84. Now, the third question is,
Thank you, sir.
Sorry?
Thank you.
Yeah. So the third question is, what should be the minimum number of successful persons we should have if we can conclude that the drug is successful? Assuming all other numbers are same, do not change the other numbers, use Yates correction. So basically what we did here, we have to do the same thing, same calculation, but now we have to change this number, number of people in which the drug lowered the blood urea level. So here, since for 45, we get a chi-square value of 1.74, but we know the critical chi-square value is 3.84. So we need a number which gives us a value of greater than 3.84. So the required value for chi-square is 3.84. So when we repeat all the calculations with changing all the values, we see that for 46% it turns out to be 1.9, 47 2.1, and so on. And finally, at 56%, we get a chi-square value of 3.9, which is greater than our required chi-square statistic value. So therefore, we conclude that the minimum number of successful persons in the trial should be 56. So basically, we are running all the same things again and again by using different values for the successful number. I'll just show it to you in Excel once.
Sorry,
can you just repeat that point? You're running the calculations, that is the calculations in the earlier.
Yeah.
Still you're
So
substituting.
yeah. Can you guys see this?
Yeah.
Yeah. So focus on the left side here. So this is the table that we are given. We are given 45. Then we calculate the expected table. We
Yeah.
calculate this table and the final table, and we add these all up to get the chi-square value. So now what I'll do is I'll just change this value to 46. Then the chi-square is updated to 1.9. And I'll continue doing that. 47, 48, 49, 50. And the chi-square keeps on increasing. Then we see when we arrive at around 56. So 55, the value is 3.7. What we need is 3.8. So when we input 56, the value goes to 3.9. So that is the answer here.
So, of course, I mean, for calculating this, I think you'd need the Excel for it to move faster. But then we don't have the Excel option in the exam.
No, for exam, you don't have Excel. So I suggest if you have a question like this, what you should do is you should choose random values which are quite high. So here from 45, you could have directly chosen 50 or 60.
Okay.
And then calculate it.
But it's not a multiple choice like that.
Yeah, it's kind of difficult, but that's the way to go.
Okay, that is now what is the minimum number of persons who should be included in the drug category? That's the meaning of that question, right?
Who should have like on whom the drug is successful? So for whom the drug.
Okay, so that category, but lowered blood urea.
Blood, yeah. Lowered blood urea, that category.
Okay. So randomly we should just substitute in our calculations and try and see which is suitable. Like there is
Substitute in
+5.
our calculations as it?
No, that is in that category. Now 45 is what is mentioned, and what you
you'll
mentioned.
input X.
Yeah, where
you can try that. It turns out to be a very difficult quadratic equation. It's much easier to solve it this way.
If you have the option of Excel, yes, but without Excel, it'll be lengthy.
Without Excel also, you could try, like, instead of calculating all the values serially, how I would go about is, like, from 45, I would go to 50. And you see 50 gets a value of 2.6, which is not enough. So you'll get to 60. Then you'll see that 60 is quite high. Then you'll get to 55 and so on. Like, you have to do fewer calculations, but you do have to do calculations.
Okay, fine.
Yeah. So substituting X, like solving that will be much more difficult because for calculating, like, for even if you input X here, this expected table you will get easily. But then to calculate this one, you will get 2-3 quadratic equations in X.
Yeah. Problem.
Yeah, this whole summation will be quite chaotic. Yeah. So is that clear for everyone?
Yes.
Yes.
Yeah. So for the next set of questions, we are given 3 baby food formulations were given to children, and the number of children who liked or disliked each of them is listed. So we have 3 baby food formulations ABC, and the number of children who liked it and the number of children who disliked it. So the first question is, what is the chi-square calculated without Yates correction? So we'll again do the same thing. We'll get a total value from the observed table for each row and for each column. Then we'll get a final total here. For the expected, we'll calculate in the same way. So for like this cell, which is A liked, it will be 31 by 104 multiplied by 50, which turns out to be 14.9. And for B, it will be 35 by 104 into 50, and so on. We'll get all these values. Then, since we are not asked about Yates correction, what we'll do is we'll just subtract observed from expected to get these values. So this is 13 minus 14.9, which is minus 1.9, 18 minus 16, which is 1.9. And then we calculate the observed minus expected square divided by expected. That's how we get all these 6 values. Then we add them up to get the chi-square value, which in this case is 5.6. Is that clear?
Yes.
Yeah. Then the 5th question again is, what is the table chi-square value for 95% confidence interval? So for 95% confidence interval, we need to look at this column. And here in the question, we are given 3 categories of baby food formulations and 2 categories of liked and disliked. So here the degrees of freedom will be number of rows minus 1 multiplied by number of columns minus 1, which will be 1 into 2, which is 2. So we'll look for degrees of freedom 2 in this column, and it gives us the value of 5.99. Is that clear?
Yes.
Yeah. Then for the 6th question, yeah.
Just missed the last bit. If you could repeat it, please. Yeah.
Yeah. So since we are given 3 types of baby food formulations in 2 categories, liked and disliked.
Okay.
So the number of columns we have is 3, number of rows we have is 2. So the degrees of freedom will be number of rows minus 1 multiplied by number of columns minus 1, which is 1 into 2, 2. And since we are given to calculate the 95% confidence interval, we'll look at this column, which is 0.05. And for degrees of freedom 2, we get the value 5.99.
Fine.
Yeah. Then the last question here, it's for one-sided test at p is equal to 0.05. We need to say if these formulations, if there is a real difference between these formulations or if there is no difference. So we calculated the value for the chi-square statistic to be 5.6. So in chi-square, the null hypothesis is the formulations are same, and the alternate hypothesis is there is a difference between those formulations. So yeah, the critical value that we got from the table was 5.9. Since our obtained value is less than the critical value for a one-sided test, we say that the null hypothesis is true. There is no difference. So the answer here will be option B. There is no real difference between each of these formulations. Is that clear?
Yeah.
Yeah. So does anyone have any doubts in all of these questions or in any previous assignments? I think this is the last question, yeah.
Was any action possible on that 1.65, that decimal matter?
Yeah, I have emailed them. They are yet to reply to my email, but for assignment 5 and I think other assignments, wherever you have to round off, they have mentioned in brackets that you need to round off the answer to 2 decimal points or something. So I think they got a look at the email, but they are yet to reply back. Just wait for a few days.
Yeah.
I think by next week they should reply.
Arpit, in which condition our answer would be insufficient data?
In which condition your answer will be insufficient data? So insufficient data, you would say if you have very less values and your answer is very close to the critical value that you obtained. So for example, here you are given like numbers like 13, 13, 24, 18, 22, 14. So if you are given numbers like 3, 3, 2, 1, 2, 1 or something like that, and then you calculated a value and you got a value which was close to or greater than your critical value or something very close, then I would say you should say insufficient data, because even though it might be significant for these few numbers, it might not be the case if you increase the data. So insufficient data, you mostly say when you feel like the data set you are using is quite small. The samples that you have are quite small. And I think cannot conclude should come like, again, the same case that we discussed last time, that it passes a one-tail test, but it does not pass a two-tail test. I think that's when you say cannot conclude as something.
If it falls between one tail and two tail, like
Yeah, falls between one tail and two tail.
Or like suppose it is just marginally higher than the critical value, like suppose it becomes 6.01, like that, still.
Yeah, then also you can say insufficient data. Like if you
insufficient
feel
data.
like the numbers are too low.
Ah,
But if the numbers are high and even if it marginally crosses the critical value, then you say that it is significant.
it is significant. Go by the one tail.
Yeah.
Option.
For here, it has asked for one-sided, so we are going by the one-tailed question.
Sir, can you please show first two questions? I joined little late.
Sure. So for the first two questions, we are given this table where we have a placebo and a drug, and in how many people it lowered the blood urea, and in how many people it did not. So the first question here is, what is the chi-square calculated using Yates correction? So from the observed table, we add all the rows and columns to get the total values. Then we add all these values to get the grand total. Then we build a expected table. So here what we do is for each cell, we divide the row total by the grand total and multiply it to the column total. So here it will be 69 by 132 multiplied by 54. Here it will be 63 by 132 multiplied by 54 and so on. Then because we are using the Yates correction, what we do is observed minus expected. We take the modulus of that and we subtract 0.5. So 24 minus 28, we take the modulus and we subtract 0.5. That's how we get this value. And for this value, we do 30 minus 25 and subtract 0.5 and so on. We get this table. Then from this table, we make another table. So here we have the square of the Yates corrected value divided by the expected value. So the chi-square statistic is given by sum of all of these values, observed minus expected minus 0.5 whole square divided by expected. So now in the finite table, we are calculating this value for individual cells. So what we are doing is we are taking square of this table and subtracting it, dividing it by the expected values for each cell. Then we add all of these to get the chi-square value of 1.74. Is that okay?
Yes, sir. All four values are added.
Yeah. So all four values will add to get 1.74.
Okay, sir. Clear.
Then for the second question, we are asked what is the table chi-square value for 95% confidence interval. So in the data set, we have two treatments, that is drug and placebo, and we are given two columns, that is whether it lowered the blood urea or whether it did not. So to find the degrees of freedom, what we do is we subtract 1 from each the number of rows and number of columns and multiply them. So it's 2 minus 1 into 2 minus 1, which turns out to be 1. So the degrees of freedom of the data set is 1. And for 0.05, which is 95% confidence interval, we say the value turns out to be 3.84 from the table. Yeah. Is that clear?
Yes, sir. Thank you.
Yeah.
So could you explain question number 6, sir?
Okay. So yeah, for this data set, we are given question number 6. So here we calculated the chi-square value in question number 4, which turns out to be 5.6. In question number 5, we saw the critical value for this data set, which turns out to be 5.99 critical chi-square value. In question number 6, we just have to compare both of them. Since the value we obtained from our calculations is less than the critical value, the null hypothesis holds. And the null hypothesis is the hypothesis of no difference. So the answer here will be option B, that there is no real difference between any of these formulations. Is that clear?
Can I?
Okay, sir.
Yeah.
Can I just see that question 2 in your assignment, what you're discussing now?
Yeah.
Just a question I
Question?
wanted to see. Question 2.
Question 2.
Yeah.
Yeah.
Here in this particular question 2, in your assignment, what you're discussing now, they have specified 95% confidence upper bound. They have prescribed. But in this assignment 5, which we have to submit now, that 95% confidence is not specified. Do we assume it or no?
Yeah, I think you should assume 95 confidence interval and upper bound.
Okay.
That's how they solved it for the previous year also. In the previous year's assignment, the question was like, what is the table chi-square value, but nothing was mentioned. So they took the 95% confidence interval and the upper bound.
Okay, so that assumption has to be made.
Yeah.
Okay.
That should hold.
So one question, how does one decide one table or two tables?
Sorry?
If it is not specified, how does one decide one table or two tables?
Could you speak a little louder? Not able to hear.
How does one decide one tail or two tails and it is not specified?
Yeah, so that depends on the question. So here we want to know if the drug is effective. Right. So you want to see if there is a, like, if the drug is working. So if it's like better than the placebo in some way. So in this case, we'll do a one-sided test. But if we have a question where we are not sure, like we want to see a difference, but we don't know in which direction we want to see a difference in. So let's say you are given heights of students from class 11 and heights of students from class 12, and you are asked like samples of heights, and you are asked, is there a difference between these two distributions or these two like population of students? Then you would use a two-tailed test because you don't know like which direction it might go to. Right. On an average, it might be same. It's better, yeah. Let's say you have data from two sections of the same class. Then you don't really know if one of them is taller than the other or something. You just want to know if there is a difference. In that case, you use a two-tailed test. But in cases like this, where we are trying to find if a drug is effective or if it works better than something else, then we know that we have to do a one-tailed test to see like if it's better than the alternative.
Okay. Thank you, sir.
Is that clear?
Yeah, sir. So
Yeah.
is there a possibility of giving the link which will be there for the exam for calculation purpose? Because practice is through calculator or Excel.
Possibility of still can't hear you, sorry.
The tool that will be used for calculation during the exam for practice during these weeks. Because you get used to Excel, for example. Graph has
Yeah. So you will be given an online calculator in the exam, and I think they'll share you the link a week or two before the exam, so you can be familiar with how it works and all.
But can it be shared before, like in the current week we are running?
That depends on them, like whoever is hosting the course. So they do share it 1 week before. I think that's what is written in the guidelines.
Actually, I asked this question during the first week, and they said that about a week or so in advance. That's about their answer. Exactly when they haven't specified. They said that they will share it in advance, a week or little more kind of answer they gave. Not very clear.
Yeah, but it will be just a calculator. It won't be Excel or something. So I don't think you will need that much time to figure out how it works.
Yeah.
Actually,
And sorry?
available and on YouTube. These
Yeah, continue.
Calculators, NPTEL calculators, because they need some basic calculators.
They need?
They need some practice, especially for statistical calculations. And
Yeah.
they are available on YouTube. And you can download
Yeah,
them.
if you
And send the request to support, and they will send you the link for the calculator.
then you guys can do that, right?
How do you write to?
Practice. It's a lot of time. Because calculating standard deviation. These are just basic calculators. The calculators that they provide in the test is just a basic calculator.
Okay.
What
But
is
like,
that is available on YouTube? Would it be relevant to this?
On YouTube, you have you can just search for NPTEL calculator usage tips, and there are a lot of YouTube videos.
Okay.
This is setting is basic calculator. You need to understand.
Voice is not clear.
Take some practice. The display is different from the basic scientific calculator. Sir, I have a question.
yeah.
In question 6, shouldn't
Yeah.
C and D be combined together? You know, there may be times when we have the value coming close, and it could mean insufficient data, and so I cannot conclude. If I have different options, then I do not know what to click on.
I felt that there's an overlap between option C and D.
Yeah, insufficient data can be included and cannot conclude, but they have given this option so that they want to know if you can figure out what exactly, like why exactly you cannot conclude something. So it might just be the case that you cannot conclude because the value falls between that of the one-tail test and the two-tail test, and you're not sure which one to use. Or it can be that you have a very small subset of data and you think that the pattern might change or be affected if you have more data. In that case, you will select insufficient data.
But in that case, also I'll get a.
That case also you can say cannot conclude, but if you like, yeah, option C is kind of a subset of option D is what I mean.
Okay. But when we are given the options, I think they should all come together.
Given the options?
You know, C and D options should be combinedly provided.
Hmm. Yeah, but still, like, they want to know if you can pinpoint, like, is it because of insufficient data or something else? Probably that's why they have given separate options. But yeah, they can combine it also.
Because when we're choosing the options, now let's say I have a value where, you know, I cannot conclude. I can also pick insufficient data. If the value comes in between the two tail and the one tail, if I have sufficient data, then I will be able to conclude this.
That also depends. So if you have 100 or 200 data points and still your value comes between one tail test and two tail test, then you can't say that you have insufficient data.
But
if you
that
have a large chunk of data.
The data.
Sorry?
I will not know unless and until I have the data.
Yeah, I'm saying like if you have 100 data points and you do get something which is in between both of them, then like saying insufficient data does not make that much of a sense. You can say cannot conclude because 100 is a quite a lot in like experiments, like biomedical experiments and like disease trials and stuff.
Hmm. I understand your
And yeah.
exact point of view. I might be confused as to which option to choose.
Yeah, I think you can club these together, I guess.
Usage purposes, your point of view is okay. Exam point of view, providing me with option C and D.
This time also they have provided the same options.
As it happens in this particular question, neither C or D is the right answer, but we'll be caught in a difficult position if the make a choice between these two.
Probably the answer might be D, but for the exam,
if anyone marks C, they'll lose the mark. That anxiety.
So like if you raise issues about the questions, they give you grace marks if they feel like the answers that were given were not sufficient. That's how it happened for last time. And I think that's what will happen for that rounding of question. So in case you get an answer like that, yeah, you should fill it out in the feedback forms. Right.
In one assignment we last discussed something.
Sorry?
Question 1, assignment 3.
Yeah, I have written them about it. They haven't replied yet.
I have one more question.
Yeah.
This is regarding question 6 in assignment 1.
Question 6 in assignment 1. Okay. Just a second.
It says use Poisson distribution.
Yeah.
But this is only a 10 people population. And it's a success failure type problem. So shouldn't this
That's
be
why it has specifically mentioned use a Poisson distribution.
it says use Poisson distribution, but ideally it should be a binomial distribution because this is a
ideally it should be binomial, but yeah, it depends on the question. If they want you to use Poisson, you have to use Poisson.
Okay.
So when they set these questions, they don't like if they don't mention anything, then you would have used binomial here. But since they have mentioned, you have to use Poisson.
Okay.
In real life, if you have something like this, it's better to go with binomial.
So I have one more question.
Yeah.
Under what situations do we use the odds ratio?
The odds ratio.
Effectively.
Sorry?
I mean, what use of having the odds ratio as opposed to calculating a mean table? You have the normal statistics, mean, medium, mode statistics. When do we use the odds ratio?
Odds ratio is a bit different from mean.
I understand, but in what situation that is likely to have a better projection of correct situation?
Yeah, I think odds ratio, first of all, is So mean, median, mode, that all you generally use for continuous data.
Standard stuff.
Yeah. But for things like binary data, yes or no questions, or like, is the drug working or not working or something like that, it's like where the response is kind of discrete or categorical. There it makes more sense to use odds ratio.
Okay.
Yeah. For continuous and all, you can use means and stuff. But for discrete and all, you generally use odds ratio.
I have come across odds ratio being used in the case of clinical data, that is response to drug, like what, like the example that was shown here, the response to like reduction in blood glucose. Or
Yeah, blood urea.
I have seen odds ratio being used.
Yeah, because that is also a binary kind of situation, no? If the drug is working or not working.
Getting the table values during the exam, they provide all the tables necessary.
Yeah, they will provide you all the tables. They will provide you tables and they will provide you with online calculator, right?
The exam will be like solving the problem, like getting solution, or the MCQ type that is getting information.
Sorry, I could not hear that.
In the examination, the answering pattern will be the assignment style, like selecting an option, or the solution that we get, solving stepwise.
I think it will be similar to the assignments. I'm not quite sure.
Because most of these questions involve extensive calculations using basic calculator.
Yeah.
How many questions are we likely to get in the final exam?
I think it will be for 100 marks, right?
100 marks, but the kind of work involved in making these type of calculations, these take a long time.
Yeah.
All the calculations.
Let's just check. I think you'll be given the same kind of questions for 2-3 marks or 1 marks. And yeah, you'll be given sufficient time so that you can calculate stuff there.
Okay.
Don't think you should be worrying about that.
The recording of this session, these problem solving sessions, now it's not immediately uploaded, right, onto the website.
No, it's not immediately uploaded. I do have a bad internet connection, so I try to upload it by the end of the weekend.
Okay.
This one I'll probably upload tomorrow.
This one, is it? Today's session?
Sorry?
This session now, what we are having right now, that will be uploaded by
Yeah, it will be
tomorrow?
uploaded tomorrow.
Okay.
By tomorrow, yeah.
So we can access it tomorrow itself? Like?
Yeah.
Huh.
After I upload, you should be able to access. Yeah. So, yeah, actually, yeah. So they'll give you tables for the exam. All of the tables. Z, T, chi-square, and all. Okay. So, does anyone have any more questions regarding this or any previous assignments?
So I have one suggestion.
Yeah.
While submitting the assignment, it will be helpful if you can provide an option where it says these questions have not been answered yet. Because while scrolling, when we scroll down fast, we tend to miss a question or two. And the next day, so I didn't see one or two questions, and sometimes I'm miss answering them, even if I know the answer for that. So if there is a prompter at the end that these questions have not been answered, then probably we can go back and fix
it. Yeah. You can send an email to support regarding that.
Okay.
Yeah.
I have one doubt. Do we are allowed to take calculator in exam or what?
You'll be provided an online calculator. They'll give you the calculator, I think, 1 week before the exam, so that you can familiarize yourself with it.
Online calculator only is allowed, no electronic calculators. In fact, they make us even remove watches and so on.
Yeah, I think they mentioned they'll give you a virtual calculator, virtual scientific calculator or something.
Okay, on the exam portal or something on the screen, like.
Yeah, on the screen, yeah.
Thank you.
I think someone mentioned that you can write to support and get access to that now also. So maybe you guys can try if you want to familiarize yourself with it beforehand.
Take some practice.
Yeah.
Especially for stats, else you'll lose a lot of time. The layout.
You can just wait to support and get the link or
on YouTube where this tutorial is there on how to use them.
So is this going to be a last problem solving session? We will have
Sorry?
Is this going to be the last problem solving session, or we will have two more lined up?
No, we'll have 8 sessions total. No, this is just the 4th. So we'll have 4 more sessions. Every week till the course is over, we have sessions.
This is the 5th. Assignment 5 is the one.
This is 4th, no? We started 1 week later.
No, what we are discussing is for assignment 5, I mean.
Yeah, what we are discussing is for assignment 5. For us, for first week, I think you had to submit 2 assignments. So I discussed one and the other one was discussed by the other tier. That one we skipped over. After that, we have discussed assignment 3, 4, and 5 today. Yeah. Okay.
Also, the calculator can be downloaded as an app on the smartphone or on the PC.
Nice.
And
maybe if you have links to the YouTube or the app, you can share it on the chat so everyone here can try it out or something.
Yes, please.
Yeah, I think Gayatri, right? You were saying about that.
Yeah.
Yeah, could you please share the link also?
1 second.
Yeah. Also, like if no one else has any question, we'll stop here after she shares the link.
Hello, sir.
Yeah.
Sir, the recording of the meeting will be uploaded by
Yeah, it will
today.
be available tomorrow.
It will available. Okay, so because I've joined right now, no? So
yeah.
I will
Tomorrow, mostly before tomorrow evening, it will be available.
Okay.
I'll try uploading it by tonight, if possible.
Okay, sir. Sure.
Otherwise, tomorrow evening. Yeah.
Okay, sir. Thank you.
Yeah.
Sir, I just now tried the O minus E, what you said, observe minus the expected.
Yeah.
It's a normal minus calculation or something else?
Normal minus.
But it is not coming because I did that 24 minus 28.227 and minus
Yeah.
0.5.
For the first question, we are also using Yates correction, right?
Okay.
So in this case, what we do here is observed minus expected.
Sorry, sir, your screen is, now it's visible.
We take the modulus and we subtract 0.5. Here you have to remember two things. So when you are applying the Yates correction, first thing to remember is you take the modulus of observed minus expected. Okay, so this value will always be positive. And then you subtract 0.5 from it. And
okay.
in case this whole thing turns out to be negative or less than 0, then you take the value as 0. So let's say, for example,
yes.
sorry. Yeah. So for example, here if my placebo was 28, okay. So I would have had 28 minus 28.2 observed minus expected modulus. So that would have been 0.2. And then for its correction, I would have subtracted 0.5. So this turns out to be minus 0.3. But this value, the observed minus expected, this value cannot be negative. So that's why we won't do the subtracting here. We'll just take it as 0.
Okay. Can you please do with the 24 and 28.2272?
Yeah, so that is 24 minus 28.227 modulus.
It's not visible, I think so.
Just a second. Is it visible here?
Now the cursor is visible, yes.
24 minus 28.227, which turns out to be minus
minus
4.227. Then we take the modulus, which is 4.227, and we subtract 0.5. So we get
Okay.
3.727.
I got it.
Right.
Thank you, sir.
This we are doing for all of these. But yeah, in case we got an answer like this, we would take 0, we would not take negative. That is something you have to remember while using this Yates correction. And always take the modulus before you subtract 0.5.
Okay.
Yeah.
Thank you, sir.
Yeah. Yeah, I think. Yeah, thanks, Gayatri, for sharing that link. I think you guys can try it out, no?
Thank you so much, sir.
Yeah, I was able to open the calculator link. It's working. Working the link. No problem.
So I'll send the link on the discussion forum. I'm not able to copy it right now.
Sorry?
The YouTube link for using how to use the calculator, I will send it on the discussion forum.
Yeah, that would be great.
I'm not able to copy it right now. I don't know why.
Yeah. That's okay. You can send that and this both of these links there, so like other people can also see who are not in class. If not here today. Okay, so we'll stop here. We'll meet next week. Hello.
Okay, bye.